Alright, so this is our second tutorial on lipids. Just a reminder of that there are three major classifications of lipids that we went over in our first tutorial. We went over fats, which are triglycerides, phospholipids, and steroids. And remember that all lipids are hydrophobic, meaning that they're nonpolar and they do not like water. Alright, so what we're going to do is go back and look a little bit about fatty acids some more. And remember that fatty acids, they have a carboxylic acid group, and that carboxylic acid group is attached to a large chain of hydrocarbons, and that hydrocarbon chain can either be saturated with hydrogen surrounding all the carbons, or it can be unsaturated and have double bonds in there. So as we looked before, here are two fatty acids. The top one again is saturated fatty acid, and the one on the bottom is an unsaturated fatty acid. Now we're going to look at some more details about the difference between saturated and unsaturated fatty acids that would be good for you to understand and know for the IB exam. So first of all, what we're going to look at is some of their physical properties. Saturated fatty acids, because they are saturated, they're going to have bond angles of 109 degrees. So their angles 109.5 degrees, which are tetrahedral structures. So you should be able to see the tetrahedral structure right there, where you have basically around this carbon you have the hydrogen, carbon, hydrogen, carbon to form that tetrahedral structure there. Now, because it's saturated, saturated fatty acids are highly compact. They have significant van der Waals forces. And again, I will stress that. Saturated fatty acids have significant van der Waals forces. Remember, these are nonpolar. So they have pretty strong van der Waals forces due to the size of the chain. Now, because of that, they're going to pack heavily. So fatty acids that are saturated clump together, and with that clumping, these saturated fatty acids are going to have high melting points. Okay? So saturated fatty acids have high melting points. So therefore, at room temperature, they're going to be solids. Okay? So one more time, saturated fatty acids, they have high melting points due to the strong van der Waals forces, and therefore they're going to be solids at room temperature. Now, unsaturated fatty acids, because they have double bonds in them, as we point out here, that double bond is going to cause a kink in the chain. And we kind of mentioned that in the first tutorial with phospholipids, that double bonds in the fatty acids for those phospholipids causes kinks instead of straight chains. So you can look at, you can have a straight chain, or you can have a chain that has a kink in it. And the kink is where the double bond occurs. And because of that kink in the chain, that bending at that double bond, you might say, you actually have a 120-degree angle there. So right there is a 120-degree angle in that kink instead of being 109.5. Now what this does is it reduces the packing of the unsaturated fatty acids. They can't pack as tightly around each other. So the intermolecular forces, specifically the van der Waals forces, are weaker for unsaturated than for saturated fatty acids. Therefore, they're going to have lower melting points. So at room temperature, unsaturated fatty acids are going to be oils. They're going to be liquids instead of solids like we see with saturated fatty acids. All right, so those are going to be that's also a really important thought here on this idea. Okay. Okay, some other things you need to be aware about unsaturated fatty acids is that when you only have one double bond in the unsaturated fat, it's called a mono unsaturated fat. Okay, so with only one double bond, it's a mono unsaturated fat. If there's more than one, then we call it a polyunsaturated. Okay, so if you look at our unsaturated fatty acid right here, you will see that there are two double bonds. So therefore, we would call this a polyunsaturated fatty acid. And you need to know the difference between monounsaturated and polyunsaturated for the IB exam. Okay. Now, what we're going to do is we're going to identify two very important unsaturated fatty acids. And we're going to write those down here. We have omega 6 fatty acid, and we have omega 3 fatty acids. Okay, you need to know both of these and the difference of what they mean. Okay, so the 6. First of all, what the 6 represents or refers to is the position of the first double bond in the molecule relative to the terminal CH3 group. Okay, so at the very terminal end, you're going to have a CH. So here, just let's say here's our fatty acid chain. Here's our carboxylic acid right here. Okay. So our last carbon has a CH3 group back here. And so what we're going to do is, this is going to be carbon 1 there, and we're going to count from the end of our carbon chain there all the way up till we get to carbon number 6 way up here, and that's where the double bond, or sorry, the other way, that's where the first double bond is going to occur on the carbon 6 from the very end of the chain. Omega-3 is the same way. You're going to have your OH. You're going to have that hydrocarbon chain. You're going to have the CH3, that's carbon 1. But the first double bond is going to be found on carbon 3. The third, in other words, the third carbon from the end. And for omega-6, it's the sixth carbon from the end of the chain is where you're going to find that. So that's where we get the 3 and the 6 from, is where the first double bond is from the end of the chain. Alright? Now, where omega-6s and omega-3s are very important because these two fatty acids are going to lower a protein called LDLs. So they're going to lower LDL. And LDL stands for low density lipoprotein. And we'll talk more about LDLs in just a bit when we get into harmful effects with too much lipids in our body. Okay? So omega-6 and omega-3s are very important for lowering LDLs. And so you need to keep a mental note of that. Okay? Where do we find omega-3s and omega-6s? Mainly, we can find them in fish oils or another plant material. But fish, oils, and plants. Now, we cannot produce in our bodies omega-6s and omega-3s at all. So we have to get them through our food. So these are called essential fatty acids. I'll write that up. Essential fatty acids. And so you'll need to know that, okay? Essential fatty acids. And again, essential fatty acids are fatty acids that we have to get from our diet and we can't make in our bodies. And omega-6 and omega-3s are examples of that. All right? Alright, so now what we're going to do is we're going to start looking at the negative effects of fatty acids or lipids in general if we have too much. And fats are one of our big problems, and that is as well as cholesterol. Okay, so you need to know the negative effects quite well. So listen to this closely, take good notes, and then get in your textbook and read more up on these negative effects because they're important. Alright. So the first one we're going to look at is atherosclerosis. This is a nasty one because it is very prevalent in our society. Besides cancer, heart disease is the #1 killer in America. So having too much fat can be a major issue. So this is the idea, is you're going to have insoluble fats, which we know are lipids, and they're going to basically connect or deposit themselves on the walls of our blood vessels. And what this will do is result in a restriction of blood flow, which can result in extremely high blood pressure that leads to heart disease. So you need to know atherosclerosis very well. Again, the idea is you're going to build up a bunch of fat on our walls of our blood vessels. This causes a blood restriction or flow of blood, and literally leads to high blood pressure and heart disease. Okay. Another harmful effect of fats is obesity by creating or intaking more fat than what we use for energy can lead to obesity, and obesity can result in cancer formation. And then we have cholesterol, and you've probably heard a lot about cholesterol and the negative effects of cholesterol. Again, cholesterol is really important for our bodies. We have to have cholesterol. We need it. So we have to have a certain amount of it. But we need to be careful with the levels of cholesterol that we have in our body, specifically in our blood. The problem with cholesterol is that in fact it is a lipid. It is nonpolar. So it cannot travel through the bloodstream by itself. It has to have some help. So cholesterol is carried in our blood or transported in our blood by some proteins. One of those is called LDLs, or low density lipoprotein, and an HDL, which is a high density lipoprotein. Okay? Now, both HDLs and LDLs will carry or transport cholesterol through our bloodstream. However, LDLs does not carry cholesterol very effectively. HDLs carries cholesterol extremely well, and we don't have the issues with cholesterol if our HDLs are higher than our LDLs. Okay? So HDLs is what we want to focus on. That's what we want to have a large amount of. So LDLs protect us from cholesterol buildup in our arteries and prevents heart attacks. And so again, LDLs themselves are not cholesterol molecules, but LDLs and HDLs are proteins that transport cholesterol. And we want high levels of HDLs and low levels of LDLs, because the higher the HDL levels are, the more effective we are at carrying cholesterol throughout our bloodstream. And with the LDLs, if they're high, then they're carrying more cholesterol, and they don't do so effectively. So what happens is the LDLs drop off the cholesterol in the wrong places, or they release them accidentally into the blood vessels where they're not supposed to, and then the cholesterol begins to build up on the walls of our arteries, kind of like the fat does with atherosclerosis. The dangerous part is that because they start building up on the walls of our arteries, then other fats that are moving through there will start sticking to the cholesterol molecules. And we build up more and more fat molecules binding to the cholesterol molecules, and then this is going to cause more atherosclerosis or major blood clots. And if these blood clots stop the flow of blood, then they can lead to heart attacks. So cholesterol can be very dangerous if it is stuck to the walls of our arteries and not transported correctly through the bloodstream. Okay, so here we kind of look at some effects of HDLs and LDLs. First of all, LDLs are stimulated. In other words, LDLs are synthesized on the basis of having a high diet of saturated fats. So saturated fats and trans fats, which we'll talk more about what trans fats are later, but trans fats and saturated fats both increase the levels of LDL. Again, saturated fats and trans fats increase the LDL levels, whereas polyunsaturated fats, which we get from fish and nuts and corn oil and other things, polyunsaturated fats increase the HDL levels and decrease the LDL levels. Okay? In fact saturated fatty acids and trans fats lower the HDL levels. Okay? This is where saturated fats and trans fats can be very, very, very dangerous because it lowers our HDL levels, and we need more of those HDLs to effectively carry cholesterol. Okay. Now, we've already talked about the need for essential fatty acids. They cannot be made in our diets, and so we need them. And if we do not get essential fatty acids into our diets, it can have very, very dire consequences to us. So we need to have a proper diet of both proteins, carbohydrates, but we also need to have our essential fatty acids too in our diet. Alright, so let me kind of outline this a little bit more for us. So essentially, we have HDLs. HDLs, again, they carry cholesterol through the body, and they're important. It's what we want. These HDLs protect us from heart attacks. Okay. Unsaturated fats. Okay, unsaturated fats are going to increase our HDL levels. Okay, so unsaturated fatty acids are more important and better for us in our diet than saturated, because saturated fats are going to lower our HDLs. Okay, which is bad. And then trans fats also lower our HDL. So these two are bad, or what we call bad fats, whereas unsaturated fats are good. Okay, and we've already talked about omega-6s and omega-3s. Okay, and omega-6s and omega-3s are good unsaturated fatty acids that we need. And not only are they good for us to raise our HDLs, but they're also essential fatty acids that we need in our diet because we can't make them. Alright, so you need to know the difference between saturated, unsaturated fats and trans fats and how they affect the HDL levels. Alright, now let's look at LDLs. Alright, LDLs. Okay, LDLs, saturated fats, okay, saturated fats are going to increase your LDLs. But unsaturated fats lowers LDLs. Okay, so again, bad fats because they increase our LDLs, good fats because they are unsaturated fats, are good fats because they lower our LDLs. Okay, and so that's really important there. All right, so hopefully this helps you a little bit, gives you an idea of the importance of saturated versus unsaturated fatty acids, and why LDLs are better for us than LDLs. All right? Okay, now what we're going to do is we're going to look at trans fats here. Okay, trans fats. Okay, trans fats are bad for us. They're really horrible, actually, and in some places they're trying to outlaw trans fats. And so what we're going to do is we're going to basically talk about how trans fats are produced and why they were produced in the first place, and so forth. Okay, so when you look at basically a double bond in a unsaturated fatty acid, in the double bonded situation, so let me write out a double bond here so you can see this. So you have a double bond, and so if we have hydrogens attached to those double bonds on the same side, and then we have our carbons, and they're going to be, so our carbon chain is moving in this direction, okay? So in this form, this is called the cis, okay? The cis, that's with the hydrogens on the same side, and the other carbons that are in our chain of hydrocarbon chain is going to be on the same side, okay? Now, the cis position is the most important, okay? It is the one that is found in most natural or in natural cases of fatty acids. And so it's the cis position that makes fatty acids more healthy for us. Whereas the trans position here, so let me write this out, the trans, the hydrogens are opposite of each other, and our fatty acid chain is also opposite, like so. And this is the trans position. Okay? Now, these trans positions are not good for our fatty acid chains. It causes problems, okay? So as it mentions here on our slide here, that when we change the cis position into the trans position, what it does is it raises our LDLs. Not good, right? So trans fats raise our LDLs, and it lowers the HDLs. So that is something we do not want to happen. Okay? Well, why did we do this in the first place? Why do we make trans fats? Well, what you got to see here is that when you have certain foods that say they're partially hydrated. Partially hydrogenated. What that means is our double bond here and here's our carbon groups, our CH2, goes through an addition reaction with hydrogen, okay? And you know what addition reactions are. And so when you have hydrogen here, remember the double bond attacks this hydrogen, and we get an addition of hydrogen here. There's our rest of our chain. So we lose our double bond, and this is called hydrogenated or hydrogenated addition reaction. And the reason why it says partially, though, is because only some of the double bonds go through an addition reaction. Not all of them do. So the idea is we're going to take some of our double bonds in our fatty acids, hydrate them, with water through an addition reaction to lose some of the unsaturation. In other words, we're going to make our fatty acids more saturated in our food. Now, what does that do? Well, by modifying this, we move from a more unsaturated to a saturated. So therefore, it changes the physical properties. So we move from oils to solids by going through these addition reactions. And what's great about these solids is that they're easier to for packaging, for manufacturers to package these fats and to store these fats as solids than as oils. Transporting solid oil or fatty acids are much easier. In the solids form, they also have a longer shelf life, so they last longer. When you cook with these oils, with these fats that have gone through partially hydrated addition reactions, they're going to be able to resist heat much better. So when you cook with them, they don't break apart or whatever. Okay, but the bottom line is that in the process of going through these addition reactions, with the double bonds that do not get changed, they, under high tense temperature and pressure, they are going to change from the cis form to the trans form. Okay, so again, when we kind of reiterate this, okay, so you have a unsaturated fatty acid. We are going to change that unsaturated fatty acid to a saturated fatty acid by going through an addition reaction by adding hydrogen, just like we learned in organic chem. By doing this, it moves the unsaturated fats from oils to the saturated fats becoming solids, which are easier to package and store, and they have a longer shelf life and easier to cook with. However, in the process of changing these two saturated fatty acids, the double bonds that do not get saturated, so they stay unsaturated still, change from the cis position to the trans position, and then that creates trans fatty acids, or partially hydrated foods. And partially hydrated foods with trans fats are bad, again, because they increase the LDL production but decrease HDLs. Okay? So if that's a little bit of confusing to you, then what I would recommend is getting into your textbook and reading about trans fats, reading about HDLs and LDLs a little bit, plus come back and review this tutorial over and over again until you kind of get the idea. Okay? So these are some of the essential points that I wanted to cover in this tutorial. You've covered everything for lipids except for one thing, and that is looking at iodine addition reactions with these unsaturated fatty acids and the mathematics that go along with those. And so I'd like to cover those in class with you. So this coming week we're going to do that, and I'll kind of explain how all that works. So, and that's just iodine addition reactions, where we're looking at figuring out the saturation, unsaturation. Okay, and so we will worry about that in class. So this is it for this tutorial on that, and feel free to make sure you write down good notes and questions that you have that we can go over in class.